Okay, what's up guys? So what we're going to be talking about in this video is something that we've sort of seen lots of times before, but it's an idea that I think a lot of students get maybe caught up on. So we have this relationship between three quantities, right? So we have the part, the whole, and the percent, okay? And we said that they're related by this formula we have here, that the part is equal to the whole times the percent. Okay. And maybe as like a quick little example, so let's say we wanted to find super basic example, okay? So we have a word problem. We need to identify the three parts. So what's the part, what's the whole, what's the percent? What is 25% of 100? Well, 25%, boom, we got the percent of 100. Remember that keyword of 100? So 100 is the whole. The only thing that's left is the part, and so there's nothing in there, so the part is what we were looking for. Okay, so the part is equal to the whole 100 times the percent. And we have to turn it into a decimal, 0.25, and that is going to give us, shockingly, the 25. And this is sort of more of a common example, where the part, okay, ended up being 25, was less than the whole. Okay, the whole was 100, and the part was less than that, 25. Okay, well, that's not always the case. I know when you just kind of the terminology, part and whole. So if you're looking for part of the whole, you expect that that part is going to be smaller than the whole. Okay, but in other cases, that is just simply not the case. Okay, so let's check out another problem. Okay, so I'm going to switch now to what is 150% of 100? Okay, well now we can still use the same formula. Okay, the part is equal to the whole times the percent, turn it into a decimal. Well, that's going to give us 1.5. All right, and shockingly, 1.5 times 100 is 150. So we ended up with a part that was greater than the whole. Okay, and we're going to jump into the opening exercise now, and that will shed some more light on this topic. Okay, so it says, if each 10 by 10 unit square represents one whole, then what percent is represented by the shaded region? Okay, so each 10 by 10 unit square, that's just the two grids they have there. They're both 10 by 10, so they have 100 total smaller squares inside the bigger square. Okay, so this is another one of those problems where we are kind of lucky, okay? Because this is one of those special problems where the whole is actually 100. Okay? So, the probably the most straightforward, maybe brute force way to solve this problem is just to count the squares, okay? Because it's sort of like a 1-to-1 ratio. And that doesn't always happen, so we are lucky here. So if we just count the squares, well, we know there's 100 in that first square, right? Because there's 100 boxes and all of them are shaded, okay? In the next one, it looks like we've got 2 rows of 10 and then half a row, so that's going to give us 25. So we have 125 total total squares, okay? So remember that, so we had this formula so that the part equals the whole times the percent. Okay, we're actually trying to find the percent in this problem. So if we solve this equation for percent, we have to divide both sides by the whole, and we end up with the part divided by the whole is equal to the percent. And we've seen this before, so this shouldn't be new. Okay. So now, let's go ahead and just sort of fill these in. So they told us that 100%, or the whole, is just 100 squares. Okay? And we have 125 squares colored in, or shaded in. So 125 divided by 100 gives us 1.25. All right? And now to turn that into a percent, you know what? I should, as a decimal. Okay, because it actually gives us the percent in decimal form. And to get the actual percent, we need to multiply by 100. So that gives us 125%. So there are a bunch of different ways to do this one, but I think that one was just the most straightforward. The second part says, in the model above, 25% represents a quantity of 10 students. How many students does the shaded region represent? Okay, so there are several ways to do this. The way we're going to do it, though, is similar to one of the exercises that we did in the last lesson. We're going to sort of figure out how many students are represented by 1%. So we're going to figure out how many students are represented by one of the little squares in our diagram. Okay? So we know that 25% in the model represents 10 students. Okay? Well, to figure out how many students are represented by 1%, well, we can use this equation. To get to 1% from 25%, we simply need to divide by 25 on both sides, because we don't want to change the equation at all. So 25 divided by 25 is just 1, so we have 1%. And then this is still going to be students over here, but we have 10 divided by 25, okay? So we have a fraction 10 over 25. I recognize that they both have 5 as a factor, so I'm going to divide 10 by 5 to get 2, and 25 by 5 to get 5. All right, so 1% in our model represents 2/5 of a student. Okay? So now that we know how many students are represented by 1%, we can figure out how many students are represented by 125%. Okay? So similarly, how we went from 25 to 1 by dividing by 25, we're going to get from 1 to 125 by multiplying by 125. Okay? Because 1 times 105 is still 125. So both sides multiply by 125. So 125% represents, so we need to do 2/5 times 125. It's just fraction multiplication, so you multiply straight across. 2 times 125, 5 times 1. 2 times 125 is going to give us 250 over 5. Okay, and they both have a factor of 5, because this one ends in 0, and this one just is 5. Okay? So we are going to get 50 over 1. So 125% is 50 students. So the diagram represents 50 students.